Welcome to the Marathi ML channel. Today's topic of discussion is how to evaluate the RAG system. Thanks to Cyril, who commented in my previous video to make a video on the RAG system, and thanks for watching that. Whoever watched that video, again thanks to them as well. Okay, I'm very happy to receive your comment to your suggestion, and it will motivate me so that I'm making such a similar and the many videos around the generative AI and the machine learning and deep learning. So thank you so much. What we are going to see in today's video, that we will understand first what is RAG, then we will see advantage of the RAG, naive way of RAG. So if you watch my previous video where I implemented the naive implementation of RAG using JEMA model. So today here I'm going to explain the theory part, but if you want to do the practical implementation of that, I will recommend it to watch that previous video so that you will get the practical implementation of that as well. Then I will explain the theory part of what is advanced RAG, what is exactly mean of the advanced RAG, and in upcoming videos, in upcoming days, I will make the actual implementation of the advanced RAG. Okay, so for that I would recommend it. Please like, share and subscribe, and don't forget to press the bell icon so that you will get the notification whenever I upload the video on advanced RAG. Then we will understand the RAG evaluation. So there are different way or different metrics are available. Using that you can do the RAG evaluation. So we will see the detail and the currently available methodology to do the RAG evaluation. And then we will use the llama index, is one of the LLM framework. We will give some capability to do the evaluation of the RAG, that we will see at the end of this video. Okay, next let's go to the next point. Let's understand first what is RAG. I think everyone knows that what is RAG. RAG is something, is a retrieval augmented generation. It is one of the, you can say, NLP technique, where we will it is a combination of the two building blocks. First, it will retrieve the information. So whenever user asks the question, based on that user question, we will have vector database. It will retrieve the relevant chunks from the vector database, feed it to the LLM, and then LLM, based using the user query and the fetch information, it will do the text generation. So the RAG is a combination of two parts. One is the information retrieval and second is the text generation. Now what is the goal of the RAG? The goal of the RAG is to produce the more accurate and contextually relevant response, okay, in a text generation, right? So whenever you ask any question, it should give the relevant response, then it is only useful. Okay, so to improve the accuracy of our LLM and the relevant answer, we will use the technique called as a RAG. Now what is the advantage of RAG? The first advantage is it's a contextual relevance, right? So whenever you ask, let's say you have a PDF of your company finance data, right, and you ask some question to LLM, right? LLM may give the general, because the LLM doesn't have any information about your company finance or your organization finance. So in that situation, RAG help us and gives the contextual relevant response, okay, and information. Second advantage, it is a fast checking and a verification. So it will reduce the misleading information. Okay, it will not give the any false answer, and it is a very fast checking. It will check and give the good answer. Third advantage, it improve the knowledge incorporation, right? So for example, it is very useful in the question and answering system. So nowadays we know that all industries are trying to implement the Q&A bot, correct? So because of that, LLM is, as we know, that it is trained on the general data which is available on the internet. But when you feed your data to the LLM through vector database or the RAG system, it will definitely improve the knowledge of the RAG so that it will give the relevant answer. Third, it is very flexible and adaptable, means you can combine any type of data to the LLM. Maybe it is in the structure format or unstructured format, SQL, non-SQL, okay, PDF, image, any kind of data you can feed it, and it can easily adaptable, right? Now the one of the thing is that it is a wide range and it will save the fine tuning efforts. We know that before this RAG system we need to do the fine tuning of the model, we need to retrain the model, but because of the RAG it is not required now. Okay, you can just put your data and the LLM will give the answer related to that. So this is really saves your the training time, cost time, infrastructure time, your expertise time. Okay, so that's why I suggest this is a flexibly adaptable. Fifth advantage, it is handling out of distribution inputs. Okay, so as I seen, LLM may not have your knowledge, so it will give the relevant information, unseen information output based on this. Sixth advantage is a control content generation. Okay, so we will do some kind of modification so that the output is a control one. It is not giving the very hallucinated kind of answers or any uncontrolled answer. So it will give the it will also gives the control content generation, and the most important is reduce the bias, so it is giving the more balance and the unbiased response of the RAG system. So there are many more advantage of the RAG, but these are the some of the highlighted advantage about the RAG system. Next, this is the naive way of implementation of the RAG system. Now, if you look at this screen, whenever we feed the user document to the, so how it works, let me explain step by step. Now, first we'll go from the left where the user document is there. There are some specific Python library we call as a document loader. Now, most of the Llama Index or LangChain framework or Haystack, there are many other framework are coming with the those kind of loader through which you load the document. Then after the loading of the document, there are called as a document splitter. We split your document in the chunk. This is called as a chunking. Okay, and then those chunks are fed to the embedding model, so that whatever your textual data is converted into the embedding stuff, and those embeddings are stored into the vector store. Generally we do call as this a vector database kind of stuff. Okay, now there are multiple vector database available in the market, some of the cloud based, some of the native. Okay, so maybe I'll make one more video on that separately, but that is not the today's topic of discussion. So then we are storing those embeddings into the vector store. Okay, and there are the user queries also. So user asks the questions. Okay, and those user queries are also converted into the embedding and stored into the vector store. So based on the user query, it will search what is the most relevant chunks that I want to fetch. For example, let me give an example. Let's say there is a data of your financial company. Okay, what is the rate revenue in the year of 2023 to 24? So it will find out the relevant chunk of this revenue in all the chunks. It retrieve and submit to the LLM. Now LLM will take the user query, this relevant chunk, and there is some kind of prompt template, or you can say prompt engineering. It will generate the response. So this is I think this is a naive way of RAG system. I hope you understand what is the naive way of RAG. If you have any doubt, please feel free to comment. I'll help you to clear your doubts. Next, but there are some limitations of those RAG system. Okay, the first limitation, let me use the pen. Okay, so the first limitation, it's a low precision. Okay, now just a minute. Yeah, it's a low precision. So what do you mean by low precision? The whatever the chunks that retrieve from vector store. Okay, so these are the vector store, let's say. So whatever the retrieve chunks, let's say chunk 1, chunk 2, it may or many times this naive is not able to get the accurate chunks. So this is called as a low precisions. Okay, next is the low recall. So what is a low recall means? For example, as I mentioned in the vector store, let's say you ask the question to the that give me revenue, right? So let's say there are chunk from chunk 1 to chunk 100 contains the data related to the revenue, but it may is a possibility that naive way of implementing only fetch the chunks from C1 to C20 or C70, let's say C70. Remaining 30 chunks it is not able to retrieve. So this is called as a low recall. Okay, I hope you understand what is the limitation of naive. First is the low precision, where uh, it is not retrieve the relevant chunk. Second is the low recall, means it is not retrieve all relevant chunks. Third disadvantage, redundancy and the repetition. So many times there are repeated way of repeated answer. So you ask a different question, but it is giving the same and repetitive answer, and you get frustrated that my RAG is not working properly. Okay, it is giving the same answer. I am expecting something different, but it is giving the same answer again and again, right? Third is the context length challenge. Okay, so sometimes the context is very high, okay, and it is bifurcated in different chunks. Okay, so it is not able to retrieve the proper answer, proper context. Okay, so context length challenges. Generations are not grounded. Okay, so there is some ground truth. Okay, but the whatever generation happen is not related to the ground truth. So this is generations are not grounded. Sixth limitation is that potential toxicity and biasness in responses. So sometimes the your text generation is unbiased. Okay, so that is the again the limitation of the RAG system. I hope you understand this limitation. Now, due to this limitation, uh, there is a way to conquer this or overcome this, called as an advanced RAG system. Now, most of the parts in the advanced RAG systems are same. Okay, now there is a user document, there is a document loader, document splitter, embedding model, and this is a vector store. Okay, but these are the things that is been added. One is the hybrid search. Okay, this is also called as a sparse dense vector. Then eliminate the redundant embedding, long context reorder, re-rank the context, best match context. So these are these important things are added. There are many other components that you can add to improve your the advanced RAG system. Now, what is this sparse dense vector, or what is the mean of the hybrid search? Now, this hybrid search is a combination of two things. One is the keyword search. One is a keyword search and another is the semantic search. So hybrid search is a combination of your semantic search and the keyword search. So earlier what happened, it's a general search. So based on the keywords, it is trying to identify the relevant chunks from the vector store. But sometimes we know that there are maybe there are few example where maybe the keyword is different, the meaning is the same. Okay, okay, so in that case there might be possibility that the relevant chunks is not getting extracted. So that's why we use the hybrid search, and this is called as a sparse plus dense vector. So sparse vector is specifically used for keyword search, where there are very good libraries called BM something is available. Okay, which will help for this sparse kind of stuff. Okay, I'll share the relevant document so that you can go in depth. And there is a dense vector. So for the semantic search, they can use the SBERT or the BERT kind of transformer based model to check to do the semantic search of meaning. Okay, so this is called as the hybrid search. Second is that after once once done this, then there is a second block. It's called as a element redundant embedding. So what happened, many times it happens that many similar chunks are getting extracted. Okay, so there is some way or libraries available in LangChain also and Llama Index through which you can delete the similar chunks. Then third is the block called as a long context reorder. With this thing, what we will do, whatever the chunks are getting extracted, okay, we can do the ordering of that, okay, based on the context available in that. And the next method is called as a re-rank the context. Okay, now the context are order using the ask question, and then we need to do the re-ranking, so that the most highest relevant chunk will give the rank 1, rank 2, rank 3, likewise. So this is called as a re-ranking the context. Now I hope you understand. These are the some of the I have given the at least the brief information. We will go in depth in a separate video how it works, but this is the understanding of the hybrid, element redundant embedding, long context, and re-rank. Okay, using this, when I'll make the different video, separate video of actual implementation, I will sorry, I will again go through it. Okay, and then re-ranking, we can best match relevant context, we can extract it and then fetch it to the LLM, and then LLM will give the response. So whatever the limitation we have seen in the previous video, this advanced RAG system will eliminate that and give the good information or the good response to that. Okay, next. Now the most important point, how we can do the evaluation of the RAG. So when we see the evaluation of the RAG, we have to first check, is this content is high quality content, it is coherent, or is it a factually correct? Even is the generated evaluation is relevant and the complete. Okay, so relevancy definitely is important, but it also check whether it is a complete or not. We also need to see whether it contains any noise. Okay, it is also, is it harmful, malicious, or the toxic? Is it fast in terms of performance? So these are the some of the I can say points through which we can do the evaluation of RAG. I mean, these are the basic. There are many things, but these are the questions you should ask when you are doing the evaluation of a RAG system. Okay, so I'll repeat one more time. The first is that check, is the content is high quality, is it relevant and complete? Okay, doesn't have noise, it is not harmful and malicious or toxic, or is it fast in terms of performance? Now there are different evaluation RAG is available. Okay, so Helm, OpenAI, Alpha evaluation, there are many systems are available through which you can do the evaluation of the RAG. Okay, and here is some reference point, Medium article, which will give you this in more detail. I'll upload this PPT in my GitHub. You can download it, you can click, and you can do it. You can modify as per requirement. Okay, next. Now here is one of the chart. Okay, I copied from one of the Medium article. Okay, so if you look at this RAG evaluation algorithm, okay, it is divided into two parts. Okay, the first, where the ground truth is provided by the evaluator, and where the ground truth is also generated by the LLM. Okay, when the ground truth is provided by the evaluator, we will follow, these are the methodology. But if you don't have any ground truth, we can use LLM, and with the help of LLM you can do the evaluation as well. The first evaluation is a character based evaluation. Means what happened, character by character we will try to check, okay, and see whether the RAG is giving the proper output or not. Second is the word based evaluation, and the third is the embedding based evaluation. So when we say the character based evaluation and the word based evaluation, in that we matches how many character and words are common in the RAG output, and based on that we evaluate the RAG. In this, I'll come to this embedding later on. Let's first complete this. In this character base, as I mentioned, it do the comparison character by character, and there are some algorithm is available called as a edit distance. So using that edit distance, you can do the character based evaluation. Next is the word based evaluation. In the word based, it will do the word by word comparison of generated text and plus the output given by the evaluator. So what are the different metrics are available for this? So meteor is available, word error rate, this is the matrix is available, liu and RAGu, this kind of metrics is available for this evaluation. When you do the embedding base, so what will happen, it matches the ground truth and the RAG output by embedding. Okay, so semantic you can say semantic matching will check in the embedding based evaluation rather than character by character or word by word, because character or word may be different, but the semantic is what one of the important thing is required. So for that we have BERT score and the mover score. Using this matrix you can do the RAG based evaluation. The next is that there are some framework is available called as a RAGas framework and the GPT score. This will do the some kind of evaluation where the ground truth is also generated by the LLM. And we know that RAGas is nowadays one of the popular framework which will help you to do the synthetic data generation as well. Okay, so in the mathematical framework, it will do the calculate the effectiveness of the retrieval and the generation separately, and it will check the recall and the precision. I'll explain in detail, but this is just for your information. Okay, and in the GPT score, it will check the generated output, how it is good. You know, it evaluate the RAG output on various set of tasks or the data. Okay, so we have the RAG, and whatever the output is generated, it will evaluate on set of different tasks, different data, different evaluation object, and see how the score is good. So these are the framework is available, where RAGas is a kind of one, you can say it's a mathematical framework, and the GPT score is one of the experimental based framework. So these are the some, you can say, as of now existing method things. There are many more, but these are the standard ones where you can do the evaluation of the RAG system. Now the character base I already explained, it's a edit distance. So there are different mathematical things are available, algorithms available, using that you can calculate the distance between two characters and it will give the evaluation. In the word based evaluation, these are the some of the algorithms are available. First is the Meteor. Okay, so in Meteor it will do word to word match between the RAG output and the reference. Okay, I hope in many of your one of many of your NLP systems or the NLP task, okay, you have this kind of matrices to check, for example, sentence to sentence translation or the summarization. You came across this kind of matrix, but the same matrix we can use for your RAG based evaluation as well. So you can do the word to word match between the RAG output and reference. Okay, so the Meteor, there are many libraries available which you can use easily and give the evaluation. Second is the word error rate. So it will do the absolute matching and it measure the percentage of the word is not matching. For example, let's say the word error rate give the of 10%. So it means that the 90% text is matched with the your given task, but 10% is not matching. Okay, so this is called as a word error rate. For example, if you do the translation from one language to another language, and if you apply this matrix, and if the response is coming as a 10%, it means that 90% translation is correct, but the 10% is not matching. The next is the blue score. So in the blue score, we will use the different techniques called as unigram and the bigram. Okay, now I'll take the separate video what is unigram and bigram, and then you will come to know. But as of now, you just consider this as a black box. Using these n-grams or unigrams and bigrams, you will check the combination of words with the output in that okay, and check the blue score. Okay, generally this blue score is very helpful in the use case like a translation, summarization, like this. And this is the full form of the blue. It's a bilingual evaluation under study score. So there is a separate paper. If you wish, you can go in detail to understand in better way. The fourth is the RAGu score. RAGu score is nothing but the recall oriented understudy for distinct evaluation score. Okay, so RAGu is specifically based on the recall. So what is the recall? Recall and precision. So what is the recall? Overlapping words of the RAG output divided by total words in the reference summary. That means the ground truth, means how accurate your translation is. For example, so whatever the output is generated by the RAG system, okay, RAG system, that is divided by the total number of words available in the ground truth. It will do the comparison, it will give the recall. Similarly, in precision, it will do the number of overlapping words of the RAG output divided by total number of words in the RAG output. Okay, so the precision check the relevancy, okay, and recall check the accuracy kind of stuff. Okay, so how your output is relevant to your RAG output. Okay, so this way this RAG score will helpful, but again this blue and the RAG are relatively low correlation with the human judgment. So these are mathematically are good, but the human judgment and this score is much different. Okay, but yeah, these are the things methods can be helpful if you want to do the evaluation of the metrics. Okay, evaluation of the RAG system, sorry. Now the next is the embedding base. As I think explained already, it will create the embedding of both, that is generated and the reference text. Then it will use the some distance based measure called as a cosine similarity. Then it use the BERT score, okay, and see the similarity, okay, between the contextual and not similarity word, and give the result. For example, let's see, here is one example. A person is sleeping with his pet cat, and second, he is resting with cat. Now both meaning of this both sentence is same, okay, though well, character wise or the word wise they are different, but the meaning wise both are same. And in that case this BERT score is very helpful. Okay, now the second is the mover score. There is a famous algorithm or the mathematics, that is earth mover distance. Using that also you can calculate the you can do the embedding based evaluation, where the use case are machine learning, translation, summarization, image captioning. Okay, so what exactly the mover score will do? It will do the measure the difference between the two distributions. So these are the two distribution. It will measure what is the difference between these two distributions, okay, and it will give the score. Okay, so these are the embedding based evaluation algorithm is available. If you feel to go in depth, let me know. I will create a separate video on that. Okay, and the last one is the GPT score. So as I mentioned earlier, these are the tasks. Okay, these are the definition template, this evaluation template, and demonstrated sample. So the generated output is evaluated on different tasks like summarization or the translation or whatever, and based on that it will give the GPT score. Okay, so based on information how much or how much relevant is that, and it will give the GPT score. Okay, so I'll provide you the GitHub link of the GPT. You can go through it, but this again require a lot of explanation, so I'll create separate video for that. But the GPT score is one of the evaluator you can use. Okay, how your generated output is good, that will help to calculate using the GPT score. Now there is a one of the important mathematical framework is available called as RAGA. Okay, as I mentioned earlier, it will these are the some of the uh, methodology you can use, you can check. So first is the context precision. So precision measure the relationship between the question and the context. Okay, so whatever the information source you have provided and whatever the question you ask, it will uh, check the relationship, that based on that it will give the context precision. Second is the context recall. So recall measure the relationship between the context, that is the source, and the ground truth. Okay, so in short it is gives, can my retrieval engine extract all the relevant data? I think sometime back I already explained this precision and recall. Okay, so the same way this precision recall works. But one of the things important, it will also give the, so these are the retrieval perspective, right? As I mentioned earlier, the RAG system works on the two parts. One is the information retrieval and another is the text generation. So for the retrieval perspective, you always check this precision and you always check the recall. Okay, second is the from generative perspective. So for generative perspective, you can check, you can do these two matrices, that is faithfulness and the answer relevancy. So in the faithfulness, it capture the relationship between the answer and the context. Okay, means check whether the generated output is really coming from the context or not, it is really faithful or not. So this is called as a faithfulness. And the relevancy, it will check how your question and answer, okay, whether the answer is relevant to your given question or not. Okay, for example, if you're asking what is the revenue of year 2023 and 24, rather than giving revenue, if it is giving something different answer of definition of revenue or something else, so maybe your RAG system is not good. Okay, so answer relevancy, always check whether the answer is relevant to a question, and faithfulness, always check whether the generated answer is coming from the context or not. So these are the two metrics, is very helpful to do the RAG, and the RAGas framework is giving these two metrics as well. I hope you understand. So I hope you remember, for the generation you always check the faithfulness and the relevancy, and for the retrieval perspective you can always check the precision and the recall. These are the important advantage of the RAGas. That is, these are the things I copied from their website. The RAGas is the LLM assistant evaluation matrix to measure the performance of the application. It also monitor the performance, means it will also give the how many number of hallucination generated answer. So if the number of hallucinated answer is large, then it's maybe problematic. So you can do this monitoring. And the next is the synthetically generated diverse test data set. Okay, and the RAGA is also help to generate the synthetically diverse test data set. So those test data set you can use for the evaluation of the RAG. But in today's demo, yeah, so these are the some of the reference from where I use while preparing this video. You can go in, I'll upload it, you can watch it later. Okay, but now it's time to do the, let's go through the our implementation. Okay, so you can use the RAGas, but one of the thing is that raga require OpenAI, because behind the RAGA it will use the OpenAI model, and you will need to pay. Okay, I would really recommend, if you want to use RAGA, you can opt, you can pay some amount money. So because some of the library functions of the RAGA use GPT-4, and that is the limitation. I'm doing on the free resources, free credit, which is $5 allocated to me, using that I'm doing. So it is very difficult to use the RAGA, but I'm trying to show you practically using the same, that is the Llama index, where I can use my OpenAI APIs. Okay, so but there is nothing much difference, but if you have OpenAI key with good credit, I would recommend you can use RAGA as well. Okay, so let's try to see how this works. So first we have to install the Llama index library. Let me rerun it. Okay, so it will take some time. It's already satisfied. Great. Okay, so it will install the Llama index. These are the some of the classes that I require to do this, like generate question, context pair, simple directory loader, simple node parser. So these are some of the libraries which we will use. Then after that we will use this, I store in my secret. So from there I fetch my open API key in the OS environment file. Okay, so let me rerun it again. This block of code will connect to my drive, Google Drive, and from there I'm reading my PDF. I already mounted, so I'm not going to do it again. And here is the path from where I am reading the PDF. So this PDF, it contains the definition of let me see if I can show you. Yeah, I have already opened. Let me show you this thing. Yeah, so these are the simple document I have created. Okay, which is contain what is deep learning important. So it's a 2-page PDF, simple PDF, and I'm trying to build this RAG system using this tool, using this PDF file. Okay, so here simple directory reader, it's a function where I'm reading my all data. Then these are the node parser, where I'm dividing my PDF into the chunk size of 512. Then I'm putting all these data into the nodes and store and create the vector index. So I'm building the index with the chunk size of 512. Let me run it again. Okay, it's done. After that I create the query engine. I'm building the query engine using the vector index and asking the same question. Let's check the response. What is the difference between computer vision and the deep learning? Okay, if I hit, it will give the response, and let me see the response of that. Okay, so the computer vision is the computer ability to extract the information, insight from images and video while deep learning is a method of artificial intelligence, teaches the computer to process data in a way inspired by the human brain. Good. Okay. Then let's try to ask the question on which my PDF doesn't have any data. So who is the captain of Indian football team? Okay, let me run this. Okay, and let's see the response. So it is giving the I'm unable to provide the answer because the question is not related to the context, is that. Okay, now one thing is very important is that by default it retrieves only the two similar node. Okay, now as you can see I already run that. So whenever you ask the question it retrieve only the two similar context node. But if you want to increase the chunk, okay, rather than you want no, I want to retry the chunks from the 3 or the 4, then you can do that using the as you can see, if I want to extract from node 2, then it will saying the list is index out of range. If you want to do that, then this is the line of code where you can change the value of k so that it will retrieve from the top 3 or top 4 accordingly. Okay, now let's come to the evaluation, which is very important. Okay, so as I mentioned, there are two of evaluation. One is the retrieval evaluation, the another is the response evaluation. So when I say retrieval evaluation, it means it accesses the accuracy and the relevance of the information retrieved by the system. Okay, so whatever we retrieve, whether it is relevant or not, this is called as a retrieval evaluation. And then next is the response evaluation, means it will check the whether your response is good or not. This is called as a response evaluation. Now before that we are going to do some kind of we will create some data set. So just for the just for the time, I'm creating the number of question, like 2 question per chunk. Okay, so as I have only the 2 top k, so you can see it's generating the 4 questions. So 2 questions per chunk, so it's generating the 4 question. Now question is generated. Okay, now these are the some of the question. Let's see what are the questions my LLM has generated for the evaluation. So the first question is that how does deep learning differ from traditional method of processing data, and how is it inspired by the human brain? Similarly, it check how can deep learning technique be applied in computer vision. So these are the some of the questions LLM generated. You no need to do explicitly, but you can do it if you want to do evaluation on your own. But these are the some automated way to do the test generation. After that I'm saying work, so I'm placing my retriever so that it will only consider the first top k. Now these are the in the retrieval evaluation, these are the two metrics is very important. First is the hit rate and the second is the mean reciprocal rank. Now what is hit rate? Hit rate, it calculates the fraction of queries where the correct answer is found in the top k. Okay, so it is calculating the fraction and check whether the uh, generated answer is found in the top k or not. So in my case the top k is a 2. Okay, so if the answer is found in the top k, so my hit rate is good. Second is the mean reciprocal rank, that is called as MRR. So what MRR does? MRR evaluate the system accuracy by looking at the rank of the highest place relevant document. For example, let's say if your answer is found in the first retrieval in the first chunk, okay, then so if the first relevant document is the top result, then reciprocal rank is 1. If it is second, then the reciprocal rank is a 2. So what exactly MRR does? MRR evaluate the system accuracy by looking at the rank of the highest place relevant document. Now currently I have only one document, but when you place many documents, okay, where the answer is in multiple documents, right, and now you want to check whether the answer is coming from the first, second, third. If answer is coming or the relevant answer is coming from the first, then your MRR is 1. If it is coming from the second, then MRR is 1 by 2. If it is coming from third, its MRR is 1 by 3. So it means that uh, your vector database need to go till end, okay, so that you can do the re-ranking. So MRR literally helps to do the re-ranking of the document so that your response will be the faster. Okay, so these are already available. So these are the libraries: retriever, evaluate from metric. I place this MRR and hit rate. Okay, then I'm doing the evaluation of the QA data set. Yeah, it takes it is doing the evaluation, so it will take a bit time. Yeah, so evaluation result is completed, so it is evaluating. So this block, the display result, is for checking the result. So let me execute this. Okay, so it will calculate how much is the hit rate and how much is the MRR in the tabular format. When I execute, then I can my hit rate is 0.875. So it means that it is able to find the answer in my first two chunks, and the MRR is a 0.8125. So it indicates that, if you can see the document is less, that's why it's coming good. But if you provide many, maybe this MRR and hit rate is coming down. But the MRR, when you say the MRR is less than the hit rate, so it indicates that the top ranking results aren't always the most relevant. Okay, so so hit rate is trying to check the the generated answer from your top data. Okay, is it able to find or not? But it is not required, because your MRR is coming 0.815, means the relevant document, it is found lower than the second or third. Okay, so it always say that the top ranking is always not the most relevant. So this is what the MRR means that. Now next is the response evaluation. As I mentioned, that it is a faithfulness evaluator and a relevant evaluator. Okay, so here these are the queries that I have already shown you. So for the faithfulness evaluator, I'm using GPT 3.5. Okay, so service context 35. Okay, so here I'm using the GPT. Okay, for this, let me execute this first. And now, okay, so create the query index with GPT 3.5 Turbo. So here we are creating the query index. So this service context is responsible to generate the response for the query. Okay, let me run this faithfulness evaluator and see. Okay, now if you can see, the query is third. Okay, so what is my third query? So whatever my third query, if you look at my third query, is that one, to how the business utilizes deep learning model. Now the answer is to provide the example of specific application of deep learning in self-driving car defense system. So this is the answer. Then next is the response vector. So it will do the evaluation. It compute, this block of code will compute the faithfulness of evaluation, and here's the result. So result will be very things, but you can see in the result it is giving whether it's a passing true or not. So if it is passing true, means it means that your answer is coming from the given context. Even you can check the response to here. Okay, so this is the response. Self-driving cars utilizes a deep learning models to automatically detect the road signs. And if you look at the answer, okay, driving car defense system, medical image analysis, factory operating, highlighting the importance. So all these are coming from this evaluation result. So yes, it's good. Similarly, we have relevancy evaluator to see whether it's relevant or not. Okay, so see, it provide the example of specific application of deep learning. So yeah, the question you ask, it's relevant to that. Okay, and similarly you can check the scores as well. So these are the some of the blocks of code is available. Evaluation result is yes, passing is true. Similarly, so these are running on some of the questions, but you can run everything in the batch as well. So these are the block of code. Using this, you can do the batch evaluation runner. And now you can see the faithfulness score and the relevance score is 1, which is a very good. Okay, so faithfulness score 1 signifies that the generated answer contains no hallucinations, are entirely based on the relevant context. Similarly, the relevant score is 1.0, suggests that the answers that are generated are consistently aligned with your retrieve context and the queries. I hope you understand my explanation. I hope this will be helpful when you are doing the RAG based evaluation on your own. Okay, so Thank you guys for watching this. Please like, share and subscribe. We will see in the next video. Thank you.